What if the solution to Earth's energy crisis has been sitting right above our heads for 4 billion years, buried in the lunar dust? It's called Helium-3, and just 1 ton of it could power a whole city for a year. But there's a catch. Buried within the silent dust of the moon lies a rare form of helium, an isotope forged in the heart of stars and carried across space by the solar wind, whispering promises of nearly limitless energy. Helium-3 is not native to the moon, it is a cosmic gift, implanted atom by atom into the lunar soil over eons, untouched by atmosphere, unshielded by magnetic fields, preserved like a fossil record of the sun itself. It waits there, thinly scattered, elusive, like gold dissolved into an ocean of grey powder. On Earth, Helium-3 is vanishingly scarce, shielded from accumulation by our planet's protective envelope. But on the Moon, the story is different. The surface is ancient and exposed, a vast collector of solar particles. Every grain of lunar regolith is a time capsule, holding within it fragments of stellar breath. The idea seems almost poetic, to harvest the remnants of sunlight trapped in dust, and use them to recreate the very process that powers the stars. Fusion with Helium-3 promises a cleaner fire, a reaction that releases immense energy with far fewer of the hazardous byproducts that plague other fusion pathways. It is often imagined as a kind of cosmic alchemy, turning the simplest elements into a controlled star on Earth. But the elegance of the reaction stands in stark contrast to the brutality of obtaining its fuel. The challenge begins with scarcity. Helium-3 is not found in veins or pockets, it is dispersed so thinly that extracting it becomes an act of persistence rather than discovery. Imagine sifting through deserts the size of continents, not for nuggets, but for whispers. To gather even a meaningful quantity, vast expanses of lunar soil must be excavated, heated, and processed. The moon becomes not just a destination, but an industrial landscape, its quiet plains transformed into fields of machines endlessly churning dust. And the moon does not make this easy. Its environment is unforgiving in ways that defy intuition. There is no air to carry heat away, no weather to smooth the terrain, no protection from radiation that streams unfiltered from the sun and beyond. The temperature swings are extreme, cycling between searing heat and deep cold. Dust, fine as smoke and sharp as glass, clings to everything, infiltrating machinery, eroding surfaces, turning simple operations into constant battles against wear and failure. Energy itself becomes a paradox. To extract Helium-3, energy must be expended, significant energy to heat the regolith and release the trapped gases. Solar power is abundant but intermittent, tied to long cycles of light and darkness. Nuclear options introduce their own complexities. The very process of acquiring fusion fuel begins to resemble the challenge of fusion itself, a struggle to balance input and output, to make the equation favorable. Then there is the problem of distance. The moon is close in cosmic terms, yet still separated from Earth by a gulf that transforms logistics into a monumental endeavor. Every machine, every component, every human presence must be transported across space, assembled in an environment where repair is difficult and failure can be final. The operation becomes a delicate chain of dependencies, where a single weak link can halt the entire system. Yet the pursuit of Helium-3 is not merely about energy. It is a test of whether humanity can extend its industrial reach beyond Earth, whether we can operate sustainably in alien environments, whether we can transform other worlds without destroying them. It forces us to rethink resource extraction on a planetary scale, to confront the limits of technology and the resilience of human ambition. In chasing Helium-3, we are not just mining the moon. We are attempting to bridge the gap between planetary civilization and stellar power, to take a substance delivered by the sun and use it to ignite controlled suns of our own. It is an effort that stretches from the microscopic interactions of atomic nuclei to the vast architecture of space exploration, connecting the smallest scales of physics with the grandest aspirations of a species learning to step beyond its home world. And beneath it all, the moon remains what it has always been, a quiet witness, holding within its dust the echoes of solar storms and cosmic time, waiting to see if we can unlock the energy of the stars without losing ourselves in the process.